There are 7 polyatomic ions that I think you should be familiar with if you're getting serious into chemistry. If you don't want, first off, I'm going to show a little pattern to how to try to help you remember the formula, charge, and name for 5 of these. And then there's 2 other ones that just kind of get tacked on right here. If you just want to know the list of them, that's fine. Just skip to the end of the video. So the first 5 that have a nice little pattern to them are based in this block of the periodic table in the upper right-hand corner of some nonmetals. So I recommend you take a large sheet of paper, clean sheet of paper, with the holes across the top here, and draw out these boxes like so. Now do this in pencil. Now I drew out a 2x4 grid, and then I'm going to erase some lines because I wanted my boxes even, so I just drew them out like this. Okay. Now, this pentominoes here of 5 boxes is meant to be the same 5 boxes on the periodic table as carbon, nitrogen, phosphorus, sulfur, and chlorine. I have them left shifted because we're going to fill in a formula here. Now, when I was doing this in chemistry, like when I first started, I just memorized these suckers. And then when I first started teaching, I opened up a textbook and somebody explained this pattern, and I was like, it's just so much easier. Okay? So there's 2 patterns here to get down. The first pattern is about the number of oxygens in these polyatomic ions. So all of these contain oxygen. And there's a pattern. This row here of phosphorus, sulfur, chlorine, these each contain 4 oxygens. And this row up here of carbon and nitrogen, they contain 3 oxygens. Now there's also a pattern with the charge that's a stepping of left to right. As we step to the left, the charge changes by 1 value. So it starts with a -1 and then goes down to -2 and then goes down to -3. So look at that pattern carefully. -1, -2, -3. And that's the entire formula and charge for this row. This row follows the exact same pattern. Start at -1 and go down to -2. I'm going to put these in parentheses because I think it's helpful when writing ionic compounds and formulas and getting used to these, to remembering like what's part of the formula, what's part of the charge. So if I was taking a test and I had to, and I didn't, like if I was taking a test and I didn't have any, and I wasn't allowed notes or anything like that, I would probably practice drawing this a few times, and as soon as I got to the test, I would write this out here. So these are 7 formulas and charges, but we need to put some names to these right here. Names are really simple. Carbonate, carbon with 8 on the end, nitrate, phosphate, sulfate. Now this one's a little trickier right here. It's perchlorate. So that pattern of the arrangement on the periodic table, lay that out first. Then there's the pattern of the oxygens, and then the patterns of the charges. I said there were 7 polyatomic ions, 2 more that are very common. One is ammonium, NH4. Now this one is a cation, the only cation. And the other one is hydroxy, which is probably the best name because hydroxy is actually the atoms that are in there, hydrogen and oxygen. I'm sorry, hydroxide, because as a negative charge, we've given an IE at the end right there. Thank you.